All right, so at the top of this page, it's like all the different formulas that you need to do the different types of probability. And so sometimes there's and statements, sometimes there's or statements, and then sometimes there's given statements. So whenever there's an and statement, that's going to be when you multiply. Now, what I had my students in the last class do is over to the side. What you're going to think of, what I think when I do this is that there's multiple items selected. Then you're going to multiply. So it's almost the same word. Multiple items, you're going to multiply. That's an and situation. So like you're selecting a number and a letter. That's multiple items. You're going to multiply. Somebody is handing out multiple Valentine's cards. That means you're going to multiply. So multiple items selected is multiplying. All right, now all the rest of the situations, only one thing is selected. So if there's one item selected, you're not going to multiply, you're going to do something else. So on the or statements, that's like you're selecting one card and you want to know the probability that it's red or a queen. Or you're selecting one parakeet and you want to find the probability that it's green or male. So only one item is selected on or statements. And then the conditional probability is the last thing that we learned. And on conditional probability, it's like one item is selected, but it's under a certain condition where you already know that this is the case. So this is another situation where one item is selected. And we didn't use this exact formula. So where that P is, if you want to, you can just change it to like a number symbol. So we would like figure out the number of A and B and the number of of A. And this last thing that you know happened, always determines the denominator. Okay, so we've actually learned a lot of different things with probability. So let's just look at the first one. So Jake randomly selects a letter from the word carelessness. What is the probability he selects a vowel? So how many letters are being selected? A letter, right? One letter. So that means we're just going to, and this doesn't have an or statement or a given statement. So this is just going to be regular old probability. We want to find the probability of a vowel. So you guys try to do this one on your own. Think about the word carelessness, and we want the probability of selecting a vowel. All right, now this one takes some time because you have to count. So how many vowels did you guys count? 4 vowels out of a total of how many letters? 12. Okay. And part of your quiz tomorrow is multiple choice. The multiple choice fractions are going to be reduced, and so this does reduce to 1/3. There's 2 that aren't multiple choice, and you don't have to worry about reducing those fractions if you don't want to. It won't be wrong if you do. It's just not going to be necessary. Okay, we're actually not going to do number 2. We're going to go and do number 3, though. Okay, so on number 3, a number 1 to 30 is randomly selected, followed by a letter from the word target. What is the probability of choosing a perfect square and then the letter T? So how many things are being selected? Two things. Multiple things are being selected, right? Multiple items. We're selecting a number and a letter. And multiple items mean you're going to multiply. All right. So I'm going to take a second and I'm just going to write down. Yes, sir. Yeah. I'm going to write down the numbers 1 through 30 over on the side. That does take time, but your quiz tomorrow only has 6 questions. So if you need to do that to make sure you get the answer right, it's definitely worth your time. Okay, and so we're finding the probability of choosing a perfect square and the letter T. All right, and then we already said multiple items mean multiply. All right, so what we need to do is look at those numbers 1 through 30 and count how many perfect squares there are. So I'm just going to go ahead and highlight all the perfect squares. Now, 1 is a perfect square. It's one that's easy to forget about, but it is. Okay, so that is 5 perfect squares out of 30 total numbers. So that's probability of getting a perfect square is 5/30. And then what about selecting T from target? 2 out of 6. Very good. Right, and then if this one is on the multiple choice part, which it would if I put one like this on the quiz, then you would want to multiply that together and then let your calculator reduce it for you. All right, multiple items multiply. All right, now I am not putting a card question on the quiz just because too many people don't know what's in a deck of cards, but they do make really good questions, so that's why there's one on the review. So on example 4, Eric is randomly choosing a card from a standard deck of playing cards. What is the probability he chooses a card that is red or spade? So how many cards is he choosing? One card. So we're definitely not going to multiply. So we want the probability of a red or a spade. I'll try to draw a spade, and no promises. It's not really easy to draw a spade. So on your quiz tomorrow, when you see or, I want you to think add. All right, so whenever we're doing these or problems, we're going to add, and sometimes you're going to subtract. So when you're trying to decide if you're going to add or if you have to subtract, you have to ask yourself, can you draw a card that is red and a spade? Like, are there any red spades? You ask yourself, are there any red spades? Are there any red spades? Y'all don't know? There aren't. All the spades are black. You'll know on your quiz if there are. It won't be a card question. So if there aren't any red spades, then you don't have to subtract. You just add. Okay, do you guys know how many red cards there are? 26 out of a total of 52. Now both of these denominators should be the same. It's the same deck of cards. Do you know how many spades there are? 13. Right, and then when you add those together, it reduces down to 3/4. Okay, let's look at number 5. Now, I already looked at your quiz, and there's definitely a question like this parakeet question. It's a different type of pet, but it's set up very similarly. So this pet store has 45 parakeets, 21 blue, 9 males, 12 females, 24 green, 14 males, 10 females that are green. What is the probability of randomly chosen parakeet? One parakeet is chosen is green or male. So the probability of a green or a male parakeet. So when you see or on your quiz, what are you going to think? You have to add. So we're definitely going to add these probabilities together. Okay, can you get a parakeet that is green and male? Yes. So if the answer to that question is yes, you're also going to subtract. What's going to be on all the bottom? 45. Since there are 45 parakeets in this store. It's probably super loud. All those birds chirping. Okay. So this first fraction, whoops, I hit the wrong button. This first fraction has to do with green. So how many green parakeets are there? 24. All right. This second fraction has to do with males. So how many total male parakeets are there? 23. You add the blue and the green males is going to be 23 males. Oops. Sorry. 23. All right. And then you subtract the ones that are green and male, which is 14. Okay. And then you just type all that in your calculator. All right. And it should give you 11/15. Okay. Any questions on that? You're going to see one like it tomorrow. Okay. So let's talk about Carter and these Valentines. Carter is handing out Valentine's cards to his friends. He has 8 Batman cards, 12 Superman, 5 Captain America cards in his bag. He selects a card, gives it to a friend, then selects another card and gives it to another friend. What is the probability that both cards he selects are Batman? So, how many cards is he giving out? 2. That's multiple cards. And multiple cards or items means to multiply. So we're definitely going to multiply. So we want the probability of a Batman and then another Batman. And I know I'm going to multiply my probabilities together. Okay, so for that first one to be a Batman, how many Batman cards are there? 8. Out of a total of how many cards? 25. Okay, and he gives it away. It's gone. So now how many Batman cards are there? 7. How many total cards are there? 24. Good. All right. Now, if I put one like this on the quiz, it's probably going to be on the multiple choice. So we would want the reduced version of those fractions multiplied, which is going to be 7/75. All right, y'all okay? Bless you. Okay, let's look at these chips. I guess they're like poker chips. I don't know. A bag contains 25 red chips, 18 blue chips, and 29 yellow chips. A chip is selected, replaced, and then another chip is selected. And we're going to find each probability. So how many chips are being selected? 2 chips. So each one is selecting a chip. So multiple chips is going to mean to multiply. All right, so we want the probability that he selects a blue, puts it back in, and then selects a red. So how many blue are there? 18, good. And the total, 72 chips. Okay, and then he puts it back in, and now we want to get a red. 25, and how many total? 72. Still 72 because he replaced it. All right, and then you just let your calculator figure all that out. And it should reduce, unless I messed it up this morning, to 25/288. If you don't get that, let me know. All right, I'm having you guys try 8 on your own, please. All right, so you should end up, once it's all reduced, 29/288. Sounds good? Okay, let's look at this pizza question. So on 9 through 10, a box of pizza contains 3 cheese slices, 7 pepperoni slices, and 5 supreme slices. Mark randomly chooses a slice, eats it, and then chooses another. Find each probability. So how many slices is he choosing? How many? 2 slices, which is multiple items, which means we're going to multiply. Now, I looked at your quiz, like I said, and there's definitely one like this. It's not pizza slices, it's a different type of food. But you shouldn't be surprised if you see one like this on your quiz. All right, so we're definitely multiplying. And so the first question that he gets a cheese, eats it, and then gets a supreme. And so how many cheese? 3 cheese, good. Out of a total of 15 slices. All right, and that one's gone. Now we want to get a supreme. So how many supreme?
5.
5 out of how many slices now?
14.
Good. All right, and then that's going to be 1/14 when it all gets reduced down. And this question, the one that's similar to this, There's two of them, and they're both multiple choice, so you will want to reduce. All right, you guys try 10 on your own, please. All right, so select a pepperoni, eat it, and then select another pepperoni. We're going to multiply the probabilities together. So first time he chooses, there's 7 pepperoni out of a total of 15. And then what about the second time? 6 out of 14. Good, 6 out of 14. So one less pepperoni, one less total slice, and then that should reduce down to just 1/5. And then all the rest of these are conditional probability, which is what we learned yesterday. I don't think we're going to do all of these, but we're going to do enough. I think you're going to feel good about your quiz tomorrow. So on 11, this is one of the ones we're going to have to do, a Venn diagram. So of 318 sophomores, 140 are taking Algebra 2 and 102 are taking chemistry. 26 of those are taking both Algebra 2 and chemistry. If a sophomore is chosen at random, find the probability that he or she is taking Algebra 2 if it is known that he or she is taking chemistry. All right, so I'm going to do a Venn diagram. This first one will be for Algebra 2, and the second one will be for chemistry. All right, what number should be where they intersect? 26. There's 26 taking both. Okay, and then the people taking Algebra 2 is going to be a total of 140, but 26 have already been accounted for. So that's going to be 114 that are just taking Algebra 2. And then the people just taking chemistry are going to be the 102 minus the 26 that have already been counted. And that's going to be 76. All right. And so the question is to find the probability that this person is taking Algebra 2 if it is known that that person is in chemistry. So probability of Algebra 2 given that they're in chemistry. So who do we care about? Is either going to be Algebra 2 people or chemistry people. We care about chemistry people. Whatever second is who we care about. So there are 102 chemistry people. So we're going to put 102 on the bottom. So if we're looking at the Venn diagram, we're only looking at the people who are in chemistry. So out of those people who are in chemistry, how many of those are taking Algebra 2? 26. Good. And the ones that I put on the quiz for conditional probability are not on the multiple choice. So don't worry about reducing it unless you just want to. Just leave it like it is. It's fine. Right. And then we have these tables. And we'll definitely have a table on the quiz tomorrow. All right. So this first table, a group of cell phone owners were asked whether they had Android or Apple phones. Use the results in the table to find each probability. So I'm going to go ahead and just add all of the columns and rows just to make it easy for me when I'm answering questions. This is a necessary thing. You don't have to do this if you don't want to tomorrow on your quiz. You don't have to add it all of them. You could just add the ones that you ended up needing. All right. All right, so we're going to look at A. This A says that we want the probability if somebody is selected from this group that is a male that owns an Android. Now, are we talking about just like a certain row or column, or are we talking about everybody? We're talking about everybody. So when we're talking about everybody, we're going to do all of these 125 people. How many of those are males that own Androids? 34. And then you're done. Don't worry about reducing it on these tomorrow. It won't be wrong if you reduce it. You just risk a chance of losing points because you might do it wrong. I don't know. Okay, so on B, the probability of Apple given that it's a male. We know it's a male. So we only care about males on this one. Okay, so let's start with the bottom. So if it's males here, the number of males should go on the bottom of the fraction. 64, yeah. Mm-hmm. And then if we're just looking at the males, we're just ignore everything else in the table. The ones that have apples, I got a little delay going on, sorry, is 30. And then just leave it. Don't worry about reducing it unless you just want to. All right, you guys try to see on your own, please. Figure out what we care about. All right, what do we care about? We care about Androids. And there's 53 people that have Androids. And then out of those 53, we want to know how many are female, which is 19. Okay. And then this last table, we're not going to do all these, but this table shows the number of gold, silver, and bronze medals won in the United States and China during the 2012 Olympics. We're going to use the results to find each probability. So let's just do C and D. Why don't you guys try to do those on your own? Just C and D. Don't worry about the others. Right. So on C, we only care about China. Sounds bad to say that, but there's 88 people, 88 China medalists, I guess. And out of those 88, how many won silver? 28. Good. And then for D, who do we care about? Or what do we care about?
Gold.
We care about gold. 84 gold medals. And then what should go on the top?
46.
46 US gold medal. All right, any questions? I did see that some of you went ahead and did the rest of it. So I'm just going to write in the answers. If you have a question about it, let me know. If you didn't do these, it's fine. I mean, you're going to be fine. So tomorrow before the quiz, we're going to do a practice quiz. I know some of you don't like to practice right before the quiz, but we're going to. And then the quiz is short. Like it's only 6 questions long. So after the quiz, you'll have some opportunities to do extra credit if you want to, or do some makeup work if you want to.